Okay, today is January the 13th, 2017, and we're looking at the western U.S. water vapor loop. Right now at 9:45 p.m. we have a temperature of 49 degrees in the foothills. We have a relative humidity right now of 65%. The barometer is up at 30 inches even, and the dew point is down at 39 degrees. And we had very cloudy skies, natural clouds in the skies today. Also, there was some chemtrail haze that was visible up through some of the breaks in the clouds. There was some rain, a little bit of rain around the area in the region this morning, and also in the afternoon. Right now, what we're looking at here is a dry upper level low. This is a mid and upper level low spinning just south of Southern California right here. This should be developing into a large rainmaker. We can see that the back side of this system is actually developing just partially right here over Southern California as this circulation pattern wraps around. But there is a transmitter on top of this system, and if we go take a look at this is the southwest water vapor map, we can see that there is some development here around the back side. Other than that, this entire low pressure system has a transmitter on it, and we can take a look at the IR map right now, and we can see that there is very little rotation right here in the very center of this mid and upper level low pressure. We see there's no rotation. That's where the descending air has neutralized the counterclockwise rotation. And now right now in the foothills, right now we have strong winds. We have 35 mile per hour gusts. And that is because of this low passing right over us. If we go back to the other map here, we can see this low passed right over Los Angeles here just a couple of hours ago, 2 or 3 hours ago. It's moving to the south. And we have a transmitter right on top of this. And so we're getting gusty winds intermittently. And that is because of the RF, the descending air from this RF heat that is being generated, that is canceling out and working against the natural counterclockwise rotation. We can see this big dark area here as well. This system here should look like this thing right over here. We should have a lot of moisture. This is a developing storm, by the way, right out here. So I just want to make the comparison. These are both low pressure systems, and here we have a developing storm. Here we have just a dry upper level low that has a transmitter on it, and that's why the thing is dry, because it cannot develop. Everything, look at here, everything is evaporating as it moves into this zone. Okay, so that's what's happened. And we have, as I say, the strong winds are generated by the transmitter itself, counteracting and basically fighting the development of that system. So we have a descending air from the transmitter turning clockwise, and we have the other part of the system trying to spin counterclockwise. And that's where the wind is generated. All right, so we have, like I said, we got a storm out here. Let's take a look at some of these other maps. We have the infrared map. This system, this frontal system here. If we go back and take a look here, we have two low pressure systems up here. Everything is being forced up into the northwest and into Canada because of this high pressure. Since this is a low pressure system, we would expect to see moisture flowing into it, because high pressure flows to low pressure, and this is low pressure. So we would expect to see moisture flowing into this system like we're seeing here. We have a spiral. Everything is swirling around that low pressure. Over here, nothing is happening because they got a transmitter on this thing generating heat. That's where the evaporation is occurring. That's why we have a big dark area, several thousand square miles, tens of thousands of square miles right here of just dry air. Okay, so we'll take a look at some of these other maps. We can see this outflow right here. Everything is moving away. We have descending air in this area right here. We can see that outflow right in here especially. And that is descending air creating that outflow. You're forcing air down into this system, and that is being caused by the heat from that RF power sending air right into this area. All right, and once again, if we look at the pattern right in the very core of this system, take another look. Also, look at what's happening here as this wraps around. This moisture is wrapping around the back side, and as it moves back around, it all just burns up right out here. It just evaporates. We'll take a look here, right here. You can see that happening right here, right there. Keep an eye right here. So as this moves around and tries to get back into the vortex, it's evaporated, and of course there's no rotation right dead center because we've got heat right down on top of this. There's very little rotation. There's actually a lot more rotation out here. We can see that, not very much in the center. Okay, now here is the surface analysis map, and we can see we've got that developing storm. This is the one that's here's the Aleutian Islands. This is that one that we were just looking at that has all the moisture wrapping around it right there. This is moving to the northeast. We have this dual low pressure system up here. These are now gales, and they're both heading in the same direction to the northeast. We have a storm indicated right here off of the Canadian coast. And we've got a low pressure system right here, which is indicated to be moving right towards Washington State, Oregon and Washington. And we have a trough right over, looks like most of northern and central California right there. The rest of this is all that high pressure that is actually right on top of that low pressure system. Here's the swell report. We've got 27-foot seas right up here off of Canada where that dual low pressure system is. 27 feet there. And things have calmed down off of California. We've got about 8 to 9 foot seas all through the right here off of California, central and southern California. All right, now here is the Doppler map. You can see that right down in San Diego, there's quite a bit of rain still falling. Up towards LA, not so much. We've got some rain up in the Palmdale and Lancaster area, and out near Big Bear and near Victorville out here. Now there was quite a bit of manipulation today up near Edwards Air Force Base, which is right up in this area right here. There's a transmitter I wanted to show everyone, but first let's take a quick look at the MODIS Today map from yesterday, because I left that off of my video by mistake. But this is what the chemtrail haze looks like. All this stuff here is all chemtrail haze, and that has been sprayed over the natural clouds that are moving in to deliver the rain. And so there was quite a bit of that spraying yesterday, but we did still get a lot of rain. Here's a window we can see down through the haze and see the natural clouds right here. As we pan towards the desert area, here's the Colorado River, and we've got Arizona right here and California here. We can see quite a bit of aerosol spraying, especially right in this area. We can see a lot of lines running every which way. Lines running all over the place, every which way. Okay, let's take a look now at, there's a transmitter just, we've got Edwards Air Force Base right here, and right here at Kramer Junction, just 7 miles right up the road here, just past this little curve. Let's go ahead and zoom in, and we'll take a look at that transmitter because there may be some viewers out there that don't know what these look like. These are up on towers. They're a phased array microwave transmitter. I'm just going to zoom in, and right up here, this is exactly 7 miles. If we can find that. Okay, well, I just had this thing. There we go. It's a little further up the road, so right up here. All right, so let's zoom in. And we can see the shadow that this casts. This is a lattice, steel lattice, like you'd see on a power line. And then we have this giant radome right here. The scale, by the way, is about 50 feet. This is a little less than 50 feet in diameter, probably about 40 feet right here. This is where the radar is actually housed. Now, if we back out of here and go back over towards the road, we'll take a look at see what this actually looks like from the ground. All right, so let's spin this thing around and we'll take a look at the. Here it is right there. This is probably about probably 4 or 5 stories high, I would say. And this is where the radar is housed. And you've got power lines that go out there and feed this thing, and they beam the microwave in various directions. Pulsed power, it's not continuous, so they can use very, very high power and pulse it for just several microseconds, and that will be sufficient to burn a channel through chop up the rain pattern. So that's what these look like. All right, so just so everybody knows, in Edwards, if we turn the map and look towards the south, you can see the sign right here, which says Kramer Junction 7 miles. All right, so there you have it, the dirt road, and this dirt road just takes you right out there. Okay, so that is the report for today, and we'll just leave this thing right here. And we have some rain on the menu again for next Thursday and Friday, and just as a matter of fact, this afternoon the phones are indicating that we may get some rain on Sunday, so that's good news. And anyway, that's the report, and we'll do another one tomorrow.